LangGraph's document loading mechanism employs a WebBaseLoader to fetch and parse web content, establishing a foundational data ingestion pipeline for downstream processing. This artifact demonstrates the initialization of a document corpus by targeting specific URLs and invoking the loader to retrieve their contents. We are about to examine the setup pattern for web-based document loading, where a list of URLs will be processed to create a collection of document objects ready for further transformation. From LangChain community, document loaders import WebBaseLoader. URLs equals https://Lillian Wang, GitHub, eo/post/2024-11-28 reward hacking / https://Lillian Wang, GitHub, eo/post/2024-07-07 hallucination / https://Lillian Wang, GitHub, eo/post/2024-04-12 diffusion video / docs equals WebBaseLoader URL. Load for URL in URLs. This code demonstrates the core pattern of web document loading using LangChain's WebBaseLoader. The implementation follows a straightforward list comprehension approach to fetch content from multiple URLs, creating a list of document objects that will serve as the foundation for subsequent processing in a retrieval-augmented generation pipeline. The WebBaseLoader is instantiated for each URL in the list, with the load method called immediately to fetch and parse the web content. This pattern is particularly useful for batch processing multiple web sources, as it efficiently handles the asynchronous nature of web requests through Python's list comprehension syntax. The resulting docs variable contains a list of lists, where each sublist represents the documents loaded from a single URL, maintaining the original structure while providing flexibility for downstream processing. This approach is chosen for its simplicity and effectiveness in the initial data gathering phase of RAG systems. The trade-off here is between immediate simplicity and potential future complexity. While easy to implement, this synchronous loading pattern may not scale optimally for very large numbers of URLs. In production scenarios with extensive web scraping needs, one might consider asynchronous loading or batching strategies, though the current implementation suffices for the demonstrated use case of processing a small, fixed set of high-quality blog posts. Let's break it down. From LangChain community, document loaders import WebBaseLoader. Imports WebBaseLoader from the LangChain community. Document Loaders module, which provides functionality for loading documents from web sources. https://Lillian Wang, GitHub, eo/post/2024-07-07 hallucination /. This line contains a URL string pointing to a blog post by Lillian Wang about hallucination in AI systems, published on July 7, 2024. The string is a direct reference to an external resource that likely provides context or background information about AI hallucination concepts. https://Lillian Wang, GitHub, eo/post/2024-04-12 diffusion video /. This line contains a URL string pointing to a blog post about diffusion video models by Lillian Wang. It appears to be a reference or citation in the code, likely used as a documentation link or source attribution for related concepts. The URL itself doesn't execute any code, but serves as a static string value that could be used elsewhere in the program. Docs equals WebBaseLoader URL. Load for URL in URLs. Creates a list called docs by iterating over each URL in the URLs collection, loading the web page content using WebBaseLoader, and collecting the results. Each element in the resulting list contains the loaded document data from the corresponding URL. The implementation demonstrates LangGraph's straightforward approach to web document ingestion using WebBaseLoader. By leveraging Python's list comprehension, it efficiently processes multiple URLs in a concise, readable pattern that's ideal for small-scale RAG pipelines. Each URL gets its own loader instance, with immediate load execution that fetches and parses content into document objects. The resulting nested list structure preserves the one-to-one relationship between source URLs and their loaded documents, maintaining traceability while providing flexibility for downstream processing. This synchronous pattern prioritizes simplicity over scalability, making it well-suited for the demonstrated use case of processing a curated set of high-quality blog posts. The trade-off becomes apparent when considering larger-scale applications, where the current approach might benefit from asynchronous loading or batching strategies, though that complexity isn't needed here. The URL selection itself reveals a deliberate focus on AI research content, with each target representing a specific technical concept that will likely serve as foundational knowledge in the RAG system's corpus.
The loader pulls pages, but page content stays blank until strip conjures text from silence.